we are fortunate that we have our other speaker here today, David Allen. David is a multi-award winning former producer and executive producer, and he was the editor of the BBC Computer Literacy Project between 1982 and 1986. Since retiring in 2001, David's continued making programmes and also was instrumental in the establishment of the CLP archive, of which we're going to hear a lot more about very soon. And also David's worked closely with us here at the museum by working with the EDSAC rebuild team to make and distribute the videos that we show, showing the progress of the project and how it's been how the build's been progressing over the last few years. Assisting David with his presentation today is his son Hugo, who'll be running the presentation and playing all the videos for us. Hugo's also a former BBC employee as well. So please join me in welcoming David and Hugo.
Thanks very much. Well, the BBC is 100 years old on Tuesday, I believe. And when I was in Broadcasting House a year or two ago, I saw this technology timeline. It was a huge thing plastered up over a wall, and I took photographs of it and stitched it together, and I thought it was rather appropriate, partly because it's an interesting thing, the history of the technology of the BBC, but also at 1982, you will see the BBC Computer Literacy Project, and I was the editor and made a lot of the television programmes in that. And one of my colleagues, Steve Lowry, who did all the technical work, is here today. So we're going to tell you the story of what happened at the beginning of that. But I want to introduce you, by way of a circular route, to another bit of technology that the BBC's developed recently. It's called the BBC Genome Project. Now, the structure of the BBC is, of course, kept in the Radio Times. And if we can just look at some of the Radio Times pictures. The Radio Times, that's not episode one, volume one in 1922. Is it 22 or is it 23? Did they start the Radio Times in 22? I don't know. But anyway, here we see some pages from the Radio Times. Now, the Genome Project took all the Radio Times copies, just paper copies, and did optical character recognition on all the material. They stripped out photographs, they stripped out all the adverts because there was no copyright clearance on those, and they digitized all the text, and then they went through a whole process with a lot of people correcting the text, and they've now produced really a thing which is the whole structure of the BBC. From the beginning, not quite to the end, because I think the BBC sold the Radio Times off sometime fairly recently. But you can see there are 10 million programme entries, and I want Hugo to look for one which is particularly crucial to the history of the BBC Computer Project. It's called Now the Chips Are Down. And what comes up is a programme that was transmitted in 78? Yes. In Horizon. I'm going to get Hugo to read that to you because it's a very small script and it's also very relevant.
A machine that can read aloud, a driverless tractor, a production line without humans, a warehouse that needs no staff, science fiction fantasies that have already arrived. The reason is a 1-inch square chip of silicon called a microprocessor. For less than a $5 it can do the same job as the giant computer of a few years ago. Programmed and linked together, they promise a future that is both sensational and frightening. Offices, shops and factories are already being made more productive in a way that will cost millions of jobs. Now the chips are down. What are we going to do about it? Must we accept the widespread unemployment to come? Can we survive if we don't? Above all, why is nobody talking about it?
Now, at the bottom, the name Edward Goldwyn appears. He was the producer, and I interviewed him recently because we're doing a thing called 100 Voices, which is interviewing 100 people who work for the BBC at all sorts of levels, and that's going on the BBC Pensioners website. And he told me some interesting things about this program, and I've also learned a lot of other interesting things about this program, particularly about the politics of what was going on at the time, which partly explains how we managed to get away with it. Now, we're going to play you a little clip from the end of this Horizon program. And Ed said he'd been talking to a whole load of people, and they were very worried that the government was taking no real interest in doing anything about microelectronics, which is this new thing. And he'd done a film in an automatic factory, and he was in the cutting room, and he edited the thing, and he'd written a commentary, and he wanted a strong ending. And he ran out of film because the shot wasn't quite long enough. And he explains that that is why the film is that it is now, when we just watched the end of it, and the end of it's very powerful.
The questions shout. What is shocking is that the government has been totally unaware of the effects that this technology is going to create. The silence is terrifying. It's time we talked about the future.
Well, that's exactly what we're going to try and do now.
Horizon very, very rarely had a program which went after it, which was a discussion. But they had a discussion because the points being raised were so important. Here was a technology coming along that the government was almost ignoring, and yet it was affecting other countries, it was putting us at a disadvantage, and so on and so forth. Now, that was a very interesting program. It was, as Ed told me, was played in Parliament. A lot of civil servants were very, very worried that the government wasn't taking any notice. So it was played in Parliament, and it had an effect which was quite considerable. Now, how did it affect me? I was in the bar, as one was in those days, at lunchtime with my head of department, and she says, "There's a thing called microelectronics. I want you to see if there's anything in it." Those very words. She's still alive. And basically, she said, "We've been given some money by the Manpower Services Commission, which is a sort of government quango that's supposed to help government decide on what to do about employment and so on. And we want you to, with a colleague, go to various countries and find out what's going on and talk to people like the think tank people in this country." So we went to Germany, where we learnt that they were calling the chip the job killer. We went to Sweden, where we found factories using robots. We went to Japan, where we found automatic factories. We went to America, where we talked to people in academia and so on and so forth. And we built up a picture that ended up with us producing a report for the Manpower Services Commission, which was distributed to MPs and various other people. We get the next slide here. Timing is everything. Now, there's a crucial thing about this project that I've begun to realize more and more as we've gone on. Firstly, if we hadn't done it then, if we'd done it 2 years earlier, the technology wouldn't have been ready. If we'd done it 2 years afterwards, there would have been too much technology as a sort of competition, if you like. But also there was a crucial thing that happened in 1978-79. 78 was the winter of discontent. Do you remember? The government was terribly unpopular, and we were producing this report basically because the Callaghan government was ignoring the technology. In May of that year, there was a general election, and guess who came to power? Margaret Thatcher. Now, we didn't know, I didn't know what's going on. Basically, we'd written this report, and the report had come up with some very important conclusions, most of important of which were that we needed a public awareness campaign, and we needed to democratize the technology. In other words, we didn't want the technology to be in the hands of an elite who would keep us out. We wanted to make sure that it was a technology for all, and we wanted, therefore, to teach people how to use it. Now, in those days, using it meant programming, and probably programming in the simplest programming language at the time, which was called BASIC. The technology was very, very crude then. The ZX80, Sinclair's machine, hadn't appeared. There were machines there, Tandys and things like that, very expensive, and there were business machines, there were word processing machines and things like that. So the technology was creeping in and being very important in some ways, but not at a public level. So the question was public awareness. So we then started to think, what can we do? What should we do? Next slide. There was a model which was the BBC's adult literacy campaign, which was a few years earlier, and it was a campaign that used television programs to encourage people to think that if you can't read, you can find people to help you. And the BBC had a very big educational network at those times, and all around the country, they set up places where people could do reading courses and so on and so forth. And they, take the stigma out of it. There was a television program called On the Move with Bob Hoskins. He couldn't read. He used various techniques to help him to read. And he was taught to read by the guy who was with him. They were a removal company. And that worked very well. So that model was there. We had an educational network that was quite complete. Can we go to the next one? So this is the BBC at that time. It was confident and it was well funded because there was the BBC was still getting a lot of increased colour licence fee revenue. And it was confident, partly because of that, but also the government wasn't very hostile in those days. And we had a very important part of the BBC, which was BBC Research, which was very well thought of in the Department of Trade and Industry, and they played a very important part in what we did next. So, what did we do? I think the next clip gives us some idea. The project. There's a very long story about how the BBC Micro got commissioned. But basically, we looked at a lot of companies, they were all British companies in those days, to see what they were offering. I mean, you could go and buy kits and parts of computers and put them together yourself. It never worked. And there were some machines beginning to appear. There were things there was the Orange computing. There was, of course, Apple. There was Sinclair, and there was Acorn in Cambridge. And in the end, we had a group of people who consisted of a couple of my colleagues, DTI people from BBC Research and Development, and so on, working together to try to work out which of the companies in this country could produce a machine to our specification. And we had a specification. We wanted a machine that was very versatile, that was very flexible, that was television friendly. In other words, it had to be able to be used in a television program and produce nice, clean pictures. And BBC Research were also very interested in machines that could use teletext. You remember Rory mentioned teletext. Teletext was a way of getting information into the television set through the stuff at the top, 3 lines or 4 lines on the picture. You've probably seen the little ants moving along on old television pictures. And so that could send data. And the idea was you could pick up the data on the machine and we could run software. And that was the idea of telesoftware. So, just go back a bit, Hugo. So the project consisted of the machine, but also more important, we were, after all, the BBC, 15 television programs, television series, rather, were produced in the totality of that project. And there was also a lot of software produced. We produced software. The BBC itself produced software to run on the machine, but also people like Which came up with a tax guide that you could run on it. I can't read the rest. What does it say?
BBC Micro, flexible, expandable, TV-friendly programming courses.
Ah, yes. The National Extension College ran a course for programming, so we didn't do it ourselves. And there were advice lines and telephone lines and helplines and information sheets and all that. So there was quite an ambitious project. And it didn't just come up like that, it took a long time to produce. So the whole project has been captured now in yet another bit of technology we produced recently. Steve and I produced this. Steve did most of the hard work, I must say. And it's called the Computer Literacy Project Archive. We originally called it the Computer Literacy Archive Project, but the BBC didn't like the word clap. Now, I'm dedicating this presentation to dear old Mac, who was brilliant. He was a man who had been in computing all his life. He ran ComShare, which was a sort of computer company for producing, business software for people. So he knew his stuff, and he'd worked in Manchester, I think, in the very early days. And he was very, very good. And so he's become our sort of front model, if you like. Now, there's a website now, which is now part of the BBC, and you can see everything about the project that we did. So can we just pan down or do whatever it is we need to, Hugo? You can probably read the number of programs there are. There are probably 200 or 300 programs in there. And also in there is the ability to run BBC Micro software on an emulator. Okay, it's all fully indexed, thanks to Steve's hard work, and we can run clips from every program. Now we're going to just show you a program, one of the two programs we produced before the project itself really started. We had to do something to keep going. So we produced 3 programs called, if we go into programs there, The Silicon Factor. That went out mid-evening BBC 2 and was quite successful. We got an award at the New York Film Festival. And then we did a series for business. Was managing the micro, and this was fronted by another BBC favourite, Brian Redhead. Does anyone remember Brian Redhead? A man who was very fond of didacticism and also pronounced his words very correctly. And I'm just going to show you a chunk of this. Go to episode 4, and we'll begin the beginning of that.
Episode 2.
No, episode 4. It's the one with the line here. I think it is.
Well, microelectronics is coming to the high street, but not quite as the Not the 9 o'clock news team saw it. There are dramatic changes on the way which will affect the way that many people work. And it is all to do with this. It is called a barcode. Now, there are already familiar sites on groceries and magazines and library books. And in this program, we'll be looking at some other applications as well. But first, let me explain how they work. They are very simply a quick way of getting information into a computer system. It's as if a machine could identify a person from his fingerprints, because that is in effect what they are, machine-readable fingerprints.
So this was a program for business. This told you how Tesco's was beginning to use barcodes. I mean, many people hadn't seen barcodes before. We'd filmed them for the Silicon Factor for the first time. And they were beginning to really affect, stock control and everything else in business. So there was some 5 or 6 very interesting programs there in business, but they weren't necessarily getting the public involved. Right, so if we go on further, what are we doing next? We're going to talk about when we launched the machine and we began the first 2 series. The machine wasn't actually ready for the first series, except about halfway through it appeared, and there were people under tables keeping it going and fanning it and doing things like that. But it did sort of work. But we were also interestingly asked to present the machine to all the DTI ministers, Department of Trade and Industry. You may remember some of these people. Norman Lamont. One of them invented the poll tax. Kenneth Baker at the end was very important. Now let's go to the next slide. Here's Kenneth Baker saying to me, oh, it's a bit like a typewriter. He was Minister for Information Technology. Now, very recently, there was an interview with Kenneth Baker. Peter Hennessy interviewed him, and I picked out this bit of it because it's incredibly significant looking back.
You needed a minister to actually promote the changes that were just about to happen. And so I wrote out a manifesto, if you like, 10 points for a Minister of Information Technology, one of which was to get one single computer into every school, one to give financial support to early robotic development. And I worked up schemes and ideas to put these to Margaret, and she appointed me, and I then put that into practice. And I was given quite a lot of leeway in getting money for that. Margaret came to me when she was very unpopular, one-term Prime Minister, a witch and all the rest of it. The recession of 81 was much worse than 2008, 2009. It was a dreadful, deep recession. But Margaret wanted something nice to say, so I gave her a little package of technology measures, one of which was computers in schools, another one was supporting robotics.
Behind the scenes, there was a movement to try and get computers in schools and so on. You can see how what we were doing, and I didn't know anything about this, what we were doing fitted, meshed in very much with what the government was doing. And Kenneth Baker was very, very helpful in getting this through. And Margaret Thatcher came to the launch, and I remember talking to her about telesoftware. And the only thing she was really interested in was, could the BBC make any money out of it? But the idea was to be a free software service, you see, for schools. Okay, now we're going to show you some clips. We're going to show you a very, very early in the series a clip, just to give you a feel for how Mac talked to people who had never had a computer before.
We're going to begin to look at some of those fundamentals today. If you can follow what we do, you stand a good chance of being able to write some programs for yourself. Well, the first thing you're faced with is this rather intimidating keyboard, and you feel you want to type something in, so you type something like Mac, M-A-C, and it says mistake. The computer doesn't recognize Mac as an instruction. I do know it does recognize CLS, which is a command, and that means clear screen. I press the carriage return button, and it clears the screen. Now, on this floppy disk here, we have a program written, and I load it into this disk drive. I'm going to load that program into the computer's memory by typing another command, load. And the program name is Sticks. And you'll see why it's called Sticks in a moment. Hit return, and immediately it starts to load, and it's finished. Now, all we have to do, I always feel a bit uncomfortable once it's loaded into the machine to actually know that it's in there. And you can very quickly check whether it's actually in the memory of the machine by typing another command, list. Hit return, and there is the computer program. And it's a sequence of instructions that the computer is going to follow one after the other. You can recognize it as basic because it's numbered down the side here. You'll see we've numbered it in tens, which allows us to put in other instructions in case we want to modify the program or to correct some errors. So all we've got to do now is to run it. And you can see why we've called the program Sticks. It looks rather like the sort of trajectory of a chopstick thrown up in a Chinese restaurant.
So, now there's a lot of text on this, and I was a bit worried about this. I never like lots of PowerPoint with lots of text. But at the end of 2 series, we had these results, and they are quite remarkable, really. Firstly, we had an audience of about 2 million, and that was 19% of the reach in the population, which was quite good. The computer book, which I had to edit, sold 150,000, was it? And it was the best-selling non-fiction book for 2 years. The National Extension College, which had done the 30-hour basic course, so that people could learn to program, they'd had I forget how many, I can't read this, 160,000, with only a 2.5% dropout rate, which is extraordinary, really. Every college in further education had recorded the series, and it would also become the most popularly viewed programme in schools, amazingly, even though it was an adult education series just going out at normal times, really. The series sold to the USA and to Canada and Australia. What else have we got? We had 300,000 inquiries through the BBC's helplines. So I can imagine, you try and phone up the doctor these days, which said you are 300,000th in the queue. So there was a lot of interest, a great deal of interest. And I can't read the rest because my eyes are going.
The amazing thing is the BBC in 85% of primary schools.
Yes, 85% of primary and 65% of secondary schools had got those machines paid for by the government, and they could choose from a range of machines. So that was pretty good. Now, what's the last one?
Government-funded software.
Ah, yes. Now, the government funded a thing called the Microelectronics and Education Programme. So it put in money to produce software that the idea was it was going to be telesoftware and it could be sent out on cassettes or through the television service. But that got closed down because the BBC decided it needed to be a commercial service, and they sold this space to banks for live information and to bookies for live information on races. So much for that. Now, so at that time, we had a great success on our hands, and we decided we should do something interesting. And we had, in the BBC in those days, I think I told you, education departments with their own budgets and their own dedicated airtime. And one of the things we were able to do, which you just couldn't do now, is we took over the whole of Sunday morning for a programme. And it was live. It was a live programme, so it was people phoning in, there were people doing demonstrations, never worked with children, animals or computers. And this is the billing for it. I don't expect you to be able to read it. But it took over the whole of Sunday morning. And it's very famous for a particular sequence, which firstly indicates the perils of live television, but also how addictive they can be. And it's the famous, well, I won't say it, I think probably some of you know, but we'll run it anyway.
Line to the computer, you have to use one of two things, either an acoustic coupler or a modem. This is quite a nice acoustic coupler. It enables you just to take the telephone handset and plug it in like that, and in that way to get a very simple connection between the telephone and the micro.
The nice part about it is, of course, it can be with a little portable micro like this. The whole thing can be portable. It's battery driven, and I was using one of these in New York when I was over there with the BBC, so I could go to a local phone, put in 10 cents, dial a local number. It would get me through a satellite into the UK, into British Telecom Gold, and I'd already typed into the micro some messages I wanted to send. I'd shoot them through, and at any time of the day or night I could do it, and then of course I could read the replies as they came through. It's a nice little system.
Yeah, it's very useful. Right, let's try going in now, dialing the telephone, using this modem here and getting straight in. So we dial 9 for an outside line, and then 837-2844, and we'll see if that will ring out. I have a nasty feeling, Mac, that we're going to have a few problems this morning, partially because I think we're going to have an awful lot of lines busy, and I don't know whether we'll get through on this number. It's ringing. We'll see. And it's still ringing. And if 100 other people are also trying to ring in, we may not get in on this line. But if not, we'll go around a different way. Right, not going to get in that way, so I'm going to have to go in, I'm afraid, through packet switch system. Sorry about that. 907536131.
Now, would you explain what a packet switch system is and what
Well, all right, it's just another route going through another network, and unfortunately it's a little more difficult to go in this way, and we'd hoped we'd be able to get in the direct way. But it's another route through a national network into this London computer. I just hope fewer people are going that way. Right, that's whistling. And let's now wake up the packet switch exchange, please. And come on, reply to me. Ah, thank God for that. Right, and now it wants to know who I am. So this is the code to get in here, TL typed that wrong. Gold M, and it didn't take because I made a typing mistake. And I do hope the cameras aren't on the keyboard too well there. Right, and it now wants to know the address of the computer that we want to get through. Well, I'll try and get to the one we were getting to. 219.201.004.
That was a secret little piece of code you put in there. That,
right. Now, we are now at last through to this London computer, and that was where I was trying to get through by direct dialing. Right, British Telecom Gold, we're through. We now have to type in our identification, which we said our ID was OWL001. And the machine asks what our password is, so no cameras on the keyboard, please. The password is that. And Telecom Gold, Automated Office Services, we're through. Mail call.
Computer security error.
I think we have some hackers. I think you tempted some hackers rather too well. Illegal access. I hope your television program runs as smoothly as my program worked out your passwords. Nothing is secure.
Hacker song. Put another password in, bomb it out and try again. Try to get past logging in. We're hacking. That's brilliant. Try his first wife's maiden name. This is more than just a game. It's real fun, but just the same, it's hacking, yes.
Yeah, well, oh no, now, ACN 019, hi there, Alex from Oz and Yug. Now look, Oz and Yug, just go away, will you? We want to do a demonstration here. Go away.
I didn't know this hacking thing was going to happen. One of the reasons it may have happened, of course, did you see what the password was? You didn't see him type it.
But he said it. He said it.
No, he didn't say it. No. It was only 2 letters. And there is a theory, Steve is probably more across this, that someone had left a radio microphone on. You should never leave a radio microphone on when you're going to the loo or if you're going to the green room, because it may be that the password was somehow passed on there. Anyway, it came up. I was desperately in the gallery trying to read all the stuff that was coming out to see if it was obscene or libelous or whatever. But you could see the way that Mac dealt with it. He thinks it's a great fun, and it was terrific to work with, absolutely terrific to work with. Basically, he had been in the first series, the computer program, he'd been the expert who then told the naive interviewer, Chris Searle, what computing was all about. In the second series, he was the naive micro man. He didn't know, but he called these poxy micros. He used to call them poxy micros because he was used to big mainframe computers and things like that. And John Cole was the expert, and he was our great advisor really on almost everything, and drew up an awful lot of the BBC Basics that we now use. Now, at this point, we were going to kind of play an end thing, but I think we've got time to do something else. Oh yes, I want to talk about this. This is a letter that Margaret Thatcher sent to the Control of Educational Broadcasting. And it's very interesting if you look at the end, which I can't quite read, but she says, in effect, I've been following this project from its inception, and I hope it goes on, that the project goes on. She's been very pleased to see the results of it. Now, again, I haven't seen this, but it probably explains how we were able to go on with Microlive. Now, Microlive became live weekly, sometimes live monthly, series, and it went on for 4 or 5 years and won lots of awards, which was very good. And it became a technology magazine program with a lot of educational bits in. And it was something we also, oh yes, this is Patrick Titley, who was the director of that particular program. We used the machine a great deal in the office. We were the first production office really to use electronic mail, and we would send electronic mail to our New York reporter, who's called Frith, and he would then alter the text of the dubbing script, send it back, and then he would record it and over a music line, and we'd put it into the program. So we used a lot of it ourselves, and that was very good. But we went on, as I say, for several years. Now, one thing I haven't mentioned yet, and I think if we can find the buggy sequence, This is the BBC buggy, because we didn't just stop at producing a computer, which is here. Computer, disk drive, various other things. Doesn't have the teletext adapter. That was a thing you bought and plugged in at the side. But we were doing an awful lot on robotics. As you know, Kenneth Baker, very keen on robotics. We did a sequence called Computers in Control, where we took the whole of robotics as a subject, and I think encapsulated it very neatly. And this thing was built. It's made of what's known as Fisher Technic, which is like Lego, and it's sort of technical Lego, if you like. And unfortunately, we haven't been able to get it to work because some of the sensors don't work on this. We were hoping to have it running around the floor, but we thought now, since we've got more time, that we might show you how we dealt with something like the buggy.
A bit less intimidating. Our buggy is still trying to find its way out of the maze. The interesting thing about this is that the robot is being controlled by an artificial intelligence program. In other words, it's learning from its mistakes as it goes around the maze. But what exactly is it doing, John?
Well, as you said, Mac, it's following a very complicated program indeed. Its overall aim is to get from the start of the maze to the end of the maze, but it's programmed to be able to cope with a lot of unexpected situations on the way. For example, it might slightly miss the line, and if it does that, you'll find that it'll veer slightly to the right and slightly to the left, as in fact is doing now, until it finds itself back on the line. If we look at the screen, we can see what it's doing at any particular moment. It's turning through 90 degrees to the right to try and find another black line at the moment. Failed to find one, so it turns 90 degrees back to the left.
And all the time it's mapping out the parts of the maze that it's already visited.
That's right. So it's got in its memory a map of the maze.
And how does it do this?
Well, it's got a lot of sensors on it. In fact, there are 4 sensors on it.
So I've got another buggy here. Let's have a look at this one.
Well, there are 2 digital sensors and 2 analog sensors.
Well, clearly the buffers are the digital sensors, that's and it feeds out into the computer there. We can hear it give that. That's the right-hand one. There's the left-hand one.
Right, and it uses those to sense when it's hit the end stops, to know if it's actually touched something. Those are digital. They're just working micro switches underneath. That sensor there and that sensor there are both to do with light, and they are both analog sensors. This one, it uses to search for the bright light, and it's simply a resistor that changes its value with the amount of light on it.
And if I cover that, the reading will shoot
Drop
right
down
down.
to 70 odd and then up to 1,000 when it's exposed to the light. This one's really rather different. This sensor emits infrared light on this side, which is reflected off a surface, and then the infrared is picked up here. So it can follow either a white line or a black line and determine which it's on. That's actually an analog device, but the computer senses whether it is above a 50% level, whether it's above grey. If it's brighter than grey, it says that must be white. If it's darker, it must be black. That type of...
Move it on there, we could possibly see that, possibly.
Yes, you can see the 2 different values.
Now you can see we weren't afraid of doing something quite technical. The interesting thing was, when we did the analysis of the audience, we found firstly it was 50% men, 50% women, that it went through all social classes, and that the more technical it was, the more people liked it, which is an interesting lesson, I think, for the BBC. I mean, nowadays, didacticism is not very popular, but it's interesting you do something quite technical, but do it in an agreeable way. It can often be very powerful. Now, we've got 3 other clips which we can show. They were put in as amusing sort of final things. So I think we'll start. Can we start with the Texan thing, the pizza thing? This is one of the funniest things I've ever seen.
good time. I'm glad it's your birthday. Happy birthday to you.
Well, that's great fun and just about credible enough for the kids to rush up in the interval and peep through the curtains to find out what the guitarist Billy Bob Broccoli's up to. But they are just robots controlled by a computer. And I suppose it would be possible to program it to have them smoking a cigarette or reading a book or whatever it is that real musicians do in the interval. It may seem a very curious way of selling pizzas, but there are over 200 showbiz pizza places opened up in the US. And that means over 200 Duke LaRues. Creative Engineering is the company that designs a range of shows for pizza chains. They make all their characters in a factory in Orlando, Florida. Although the shop floor may look bizarre, it's an ordinary assembly line like any other, and this is the quality control section. This chassis will end up as Fats the gorilla we saw.
Wonderful production line, but so we use light relief like that. We were always looking for ways of showing you how you could do things on your own micro which were relevant to things you were seeing in the wider world. Now, this is something that's going to embarrass my son, but this is something we filmed in a school on the subject of graphics.
We're on there, aren't we? No, we're not. So it's not.
Crash is a program designed to help them plan ahead and think logically.
We want 9 up. No, we want to put 10 up for safety. No. Yes, we want 2. Then we'll want 2 left first.
But it's also designed to let them program the computer themselves, using a simple language with instructions like L for left and F for forward.
You print into the computer directions for it to try and go through the maze and hit the target.
How does that help you with your schoolwork, though?
I don't think it does.
Right. Last, but not least, I hope, again, it shows Mac's sense of humour. He was always coming up with wonderful sort of one-liners and things. We were out filming, I know we've seen a lot of robots. We were out filming a large industrial robot, and he was showing how you program it, using various controls of a high-level language. And this was how we decided to do the end. And I think we'll run this on together with the end credits, and that will be that. Okay, so let's just run it.
Well, despite its size and power, the robot has to be able to move with a great deal of precision. In this case, it's claimed it can move repeatedly within 1/5 of a millimetre of where it's been programmed to, and that's with 60 kilograms on the end of the arm at full speed. Well, we thought we'd put it to its test. We've put a pin in the end of the arm here. We're going to take an egg. We've programmed it to punch a little hole in the egg, and then it has to whirl around and go back through exactly the same hole. Well, there it is, just one hole. Well, you might ask why anybody would want to use a £35,000 robot to put a pinhole in an egg. Well, the answer's quite straightforward. It's to stop the egg from cracking when you boil it. Until next week, goodbye.
questions.
Well, thank you very much for that, David. It's fascinating to see some of these things again. And it's quite familiar to us as if you're a regular visitor to the museum. We see the BBCs every day. The fact that the legacy is there, and it's especially personally for me, until recently I was working on autonomous robots. You may have seen them driving around Milton Keynes delivering groceries to people. They drive themselves. They don't have anyone guiding them, and that's direct link back to this artificial intelligence as well. So it's wonderful to see. And of course, we're still teaching computing to our visitors using the BBC computer to this very day. Our educational
How do they
groups
react to it? They've no
they
mouse.
absolutely love it. It really, really is very, very popular indeed. Anyway, so we have time for some questions. So if anyone has any questions, David, if you'd like to just check to make sure there aren't any popping up on the chat. There weren't any. So Roger, if you'd like to.
Not really a question, just to answer your question. I'm one of the people on the education team. Sorry. I'm Roger Moore, I'm one of the people on the education team, and to answer your question a bit, you have to tell the children how the keyboard works differently, how they have to put a line number in, but most of them pick it up really quickly, so we get them within about 15 minutes to program 1 or 2 or 3 20-line programs, and by the end of it, they're so enamoured of it, it's hard to drag them away. They really love it.
Yes, it's very good. It was a machine designed, partly for education, obviously, but also partly to have all these inputs and output devices so that you could connect things, to them. Thermometers, so you could measure the room temperature, that sort of thing, and plot graphs, and the A to D converters were very important, obviously for driving something like the buggy. And there were 12, was it 12, or no, how many graphics modes were there? Was it 8? 8. Including teletext mode, so that you could run teletext. You remember the BBC's teletext service, which ended, I don't know when it ended, but it was, one of the first digital information systems. Any questions? We had a lot of problems when we were going to these various companies, trying to get them to tell us what they were doing. Yes, sorry.
Hugo, could you 1 second wait for the line, please?
Oh, okay.
Sorry. Hugo, could you indulge me for a second, please? Could you rerun the credits without the... You don't need the sound on. Just...
The last thing on there.
Yeah.
To stop the egg from cracking when you boil it.
And this was done... Was this done at TV Centre?
No, it was done in Birmingham.
Pebble Mill?
Pebble Mill.
Right, okay.
Why, were you there?
No, my dad's name's just about to come up.
Oh, really?
Yeah.
Ah. Really?
There, David Hughes, that's my dad.
Oh, great.
Thank you.
Oh, that's wonderful. That's wonderful. Excellent.
So I've got a question here. Sorry.
So,
Sir Clive Sinclair, why didn't he get the contract to produce the BBC Micro?
Well, we did a lot of looking at the extent to which there was upwards compatibility in the design of products from particular companies. We didn't see much upwards compatibility in that. And when we went to visit Sinclair, it was the same day we visited Acorn. Acorn had got this machine going which wasn't working properly, but could we come back later and they'd sort of get it going. Famous story about that, if you look at the Micromen. And we did go back later and it was working and it was absolutely stunning. And then we went to the pub. But in between we'd gone, in the early part of the day, we'd gone to Tangerine Computers at Ely. And then we came to visit Clive Sinclair. Now, Clive had been given, we'd sent him a, quote, specification. He said, what do you call this? It's not a specification. No, it's a list of desirable features. You know, we want sound, we want colour, we want different graphics modes, we want in and out, this, that and the other and so on, and we want a basic language which is more advanced, really, than some of the stuff he'd had. And he said, no, but I'm the most important computer manufacturer in the country. If you come with me, the world is our oyster. He says, if you don't, I'll fight you tooth and nail. And he did. Now, we wanted a keyboard which was solid and positive. You know, that's a solid, positive keyboard. He flapped around the Sinclair Spectrum keyboard, because obviously the Spectrum hadn't come out by then, and said, that's a positive keyboard. And we said, well, it isn't quite what we want. And he was really quite unpleasant. And I went back to Acorn for a drink. He did write to the BBC. He wrote a letter to the governors objecting to the whole thing, saying the country's biggest computer manufacturer had been ignored, and he got short shrift letters from the top of the BBC. The top of the BBC were totally behind us. I mean, I did demonstrations to the governors and all this sort of thing. Say, oh, it's a bit like a typewriter, and so on. But that was unpleasant, actually. But the Acorn people, I mean, they were real academics. They were really pushing the technology. They had a wonderful system going. And although when we started saying, well, we want this and we want that and we want the other, and BBC R&D, there were meetings every week to discuss the technology and the specification and so on. And then there were problems with the chips. They couldn't get the chips made in time. They kept burning out and things like that. And that's why the thing was delayed. There was a 3-month delay anyway, which was embarrassing to the BBC. And then there was another 3 months delay when we started the computer program, but we didn't have the machine. I don't think you were there for that, Steve, were you?
I was lucky enough to miss the ad series. Enjoyed it when the BBC Micro was working better.
Yes, quite. Steve, I should explain, used to be in the studio floor, part of the program team, all through the week. You know, we would plan what we wanted, and Steve would go away and write software and get things to work. And we had wonderful Fisher Technic and other things to make things out of, to explain how you can make things work, control and so on. Yeah.
Just back to the archive. The archive covers every program we did and more. The more being practically all the relevant programs the BBC has made since the computer literary project stopped. So the full archive covers everything up to explanations of why Sinclair didn't get the project, for instance. And it's searchable from the search area. You can put in Sinclair and you can find all the references to Sinclair within that project. Yes. Now, I've been continuing beyond what you can see online at the moment to digitise, archive, curate any relevant material that the BBC is still making about computers technology, because one day perhaps we'll be allowed to include more programmes in that collection. Because you can, if you walk around here, the computer literary project, the museum, there's a core store. We have an item which explains how a core store works. So there are lots of individual items which still educate and would be really useful,
I think it's still very relevant
for museums. I have a question. I've now sold you the computer literary project, which covers beyond, because when MicroLive stopped, there wasn't the internet. And to have an archive that didn't cover the internet seems foolish. So we covered the complete included programs we have here include all that and more up until quite recently.
Yeah.
But as I continue trying to find programs the BBC is making, the real sad thing to me is that the equivalent of what David made happen, I'm not sure will happen anymore in the BBC. I wish the BBC was still making inspirational programmes about technology that entertained and therefore drew people into understanding, loving and adopting the technology.
Yeah.
And my question really is, could you see the BBC now still being brave enough to educate people and trusting them to be taken in by the right people like Mac
yes, it's
to understand?
I mean, there was the BBC microbit, if you remember, a few years ago, which was an attempt to make a small Arduino-like device that would control things.
But how many programs did they make? I've got them all online.
I don't think it was promoted at all very much, was
quietly
it?
put in the background.
Yeah.
It's viewed as if it's unfashionable to try and educate people.
It's unfashionable to be didactic, I think.
But we were never preachy. We made it entertaining and involving at the same time.
Yeah, we tried to, yes.
And that should still be possible nowadays.
Yeah. Yeah, no, I agree with you. I'm constantly annoyed. I mean, I look at some of the Brian Cox stuff on astronomy, and there's very, very little content in it. There's an awful lot of walking around saying, isn't the universe wonderful? But there's very little actual science in it. And of course, they've just almost disbanded the BBC Science radio unit and sent it off to Cardiff, and most people have left. And it's going to be a much diminished service soon. I mean, it's hard. It's up against the stops. It's hard to get money now. We had reasonable money. I mean, you can tell that in the opening titles. These were not cheap things to make. Graphics designers and musicians working together to produce a title sequence cost a lot of money.
And the other thing more generally about the BBC is when we were making these series, as you've said, we had a very strong research and development department within the BBC. I still say we, although I'm retired. A lot of the technology, which wasn't directly computing, was still generated from research and development. Cameras were worked very much like the BBC Micro in cooperation with manufacturers. Now, I know things have changed in that regard, but the remnants of BBC research and development is now much reduced.
And it's all software, really.
Yeah.
Yeah. I mean, it went from the BBC making its own equipment in the very early days. You remember the famous microphone that you see General de Gaulle talking into? I think it was a BBC design, but it was made by who was it made by? Was it Marconi? One of those, anyway. So virtually everything was designed by the BBC, and then, of course, eventually they would work with other companies. I mean, we did this in a sense with the Micro, didn't we? There was an enormous amount of hostility even inside the BBC to this, because it was commercial. It was a commercial machine. We didn't have to deal with Europe in those days. So otherwise we would have had to put it out to tender to all European companies. I'd like a drink now.
So I think we've got time for a couple more questions. It's Pete. We'll take the lady in the front here, and then we'll go to Peter. Thank you.
I'm a Japanese journalist based in here for the last 20 years or so, but there is a program called the BBC Click. I wonder how you evaluate, and at the same time, I wonder why BBC Research Development doesn't really make everything in public domain, because I go to various media conventions, and there are always BBC Research and Development people, but they never relay that sort of massive amount of information to the public very much, except maybe BBC Clip.
It's part of BBC World Service News, you see. It's a difference. See, we've also lost the education departments. We've lost the on-air education departments. A lot of BBC educational material online, with bite size and things like that, but we don't have any departments anymore, so they don't make programs. There's the Open University, of course, and you see a lot of stuff is made in association with the university. All the Attenborough stuff is, for example.
You're quite right, Click is beyond its 1000th edition now, so it's obviously, add that up, half an hour per programme, let's say, that's 500 hours worth of television about technology. But does it dare to go as far as we used to do? No, maybe we're in a moment in time where that's not necessary. It's more entertainment than we'd have chosen.
Yeah, it's
to inspire and educate, I think.
It's very easy to attack. It's very easy to attack modern television techniques. I mean, they are different, and it is difficult to be didactic, or should we say, to explain things clearly. And I often think that the post-production people have too much control, in a way. Everything's very whizzy, But that's just me. I'm not half as old as the BBC. No, more than half as old as the BBC. Yes. Anyway, any more questions?
Yes, we recently had a letter into the museum asking about a programming language called COMOL. And as I remember it, it was thought well of at the time, and that the BBC thought about it, didn't adopt it, but it influenced BBC Basic. Am I remembering correctly? And if so, can you shed more light on it?
I can't. I didn't know if Steve can. Do you remember COMOL?
Did you say COMOL? No, COMOL.
COMOL, yes.
It was a basic like.
Yes. The origin of BBC Basic is quite complicated, actually. We started with a thing that John Cole was the chairman of a thing called MUSE, Micro Users in Secondary Education. And they had their own idea about what a properly structured basic for education should be. And we included that in our original specification. It was called Adopted Basic for Computers, ABC. Acorn then took that over, but they had their own basic. And I think BBC Basic, as it evolved, was really a combination of the two. There were a lot of ideas from both, I think. Steve, you know more about this than I do.
There were a lot of conflicting pushes to get the right language chosen for educating. And I suppose Pascal was perhaps another one that was an obvious contender.
Yes.
But BBC Basic, I guess in the end, it's down to the people who code it to make it possible, and the pressures to make it accessible from an early stage of playing with it ended up with what we've got. And because it provided extensions still to do a seminal language on top of that, it provided enough of a solution for people to use many of the principles of coding without some of the restrictions that some of the more formally correct programming languages at the time demanded of people.
Yeah.
So I guess it provided a more open gateway for people to at least understand the concepts of coding, whilst perhaps failing with the software police sometimes and not actually observing every rule that some of the more formal programming language might have dictated.
On your emulator, on the emulator on CLAP, CLPA, can you can sit there and write programs from scratch, can't you?
You can look at the coding. You can do a list of the coding.
You can look at the coding, but can you also just simply start writing a program?
You just do list and adjust it to suit what you want to do with it. Yeah.
So it is still possible. It's a fantastic piece of work, this, and we had to do it under the counter, and we were helped a great deal by it. No, we did. Well, we had to persuade people to find the programs. Some of those are off VHS because there was no other source. But we had to. We had friends in various places. BBC R&D were very good, and we, in the end, had to get money from elsewhere, which had to be funneled through here because the BBC couldn't accept the money directly.
The BBC wouldn't accept unless you showed them what was happening for real. You had to prove by having something already running for them to accept that this archive was going to happen.
You had to do it in order to show them that they could put some money into it.
BBC Archive have been very supportive. BBC Archive also, David has done a previous talk here about the history of the project, available on this. And at that time, David phoned up and said, have you got any old bits of programmes from the project, as in TV programmes? And we were scratching around for old VHS copies, not knowing that BBC Archive actually has every programme that we covered in their archive. It was a real one of the BBC's best kept secrets, that all the archive, somewhere we could extract that information.
Because my daughter-in-law was kind enough to send me a whole lot of stuff she nicked off the web. And so we knew there was stuff around, but it was often very poor quality. This was variable quality, but it, on the whole, it's watchable. Hope you watched it.
So I think we've got time for just one more question.
Yeah.
Pass you that.
Thank you. Not a lot to add in a sense, but I joined the BBC in 1979 as engineer. I transferred from university there because it was at the time the junction of the digital skills coming in, and I was fairly up to date on that at the time. But as time went on, I'm glad I joined the engineering division because it actually taught me how things actually worked. And then I got an opportunity to go into production. And when you start making programs, one of the dilemmas we had, and especially, for example, the higher education things for the Open University, was that the programs had to actually sit well within the community and what they would watch. And that was a complete dilemma against the academics who felt they had an absolute right to be there and perform in any way they wanted. And
Yes.
it was an awful dilemma to get that sorted out. And I do value the time I worked in the BBC as engineering, because I went into VT and post-production stuff. And I then had to learn how to save these programs. And I mean, for example, we had one program about astronomy where there was a great fog that came in at part of the program and it obscured the two presenters, and they got really upset about this, and it was all hell broke loose. And I think we had about 9 major points to correct on that. And I just could only promise about 7, but we agreed on that and the programs went out. But it was a great dilemma at that time. And also the BBC, that turning point, as somebody else mentioned, where we were starting to buy equipment in from outside to gel in with our sort of desks in television and radio. And then we all had to become systems engineers to make sure it actually fitted and worked in.
Yes.
But it was cheaper and made just as efficiently, you know, as the stuff that we were designing. And sadly, that design department, you know, really fell away. I mean, I remember once I had the job.
Designs department.
I'm sorry?
Designs department amalgamated with research.
Yes.
It became research
Yes.
and development. Yeah.
I did have a short spell with Studio Capital Projects in London, you know, where I was sent to London from Bristol, where I started off, became engineer in charge of one site, and I didn't know what the hell I was doing, you know. And then you had to have contractors in to make things. It was a very important change of time around the early 80s, you know,
Yes.
and how we all had to readapt. And
Yes.
we've lost a lot of archive stuff, and I think that's very sad that we had
It
a lot
is.
of stuff with people wanted new stuff all the time.
Yeah.
And just to finish, I think most of young people these days, you know, into electronics, which I was in, and I also volunteer at the radio centre on this site as well. We all look at YouTube, don't we? We look at superficial destinations to find things out, and there's no rigour or depth in what a lot of things have been done these days.
No.
So I'll leave it.
Difficult, isn't it? Yeah. Yes.
Excellent. Right. Well, thank you once again for coming along today, and especially to David and his family who've generously given up their time to come and
Hugo, who was brilliant. I mean, these
Thank
things
you.
only work. Yeah. These things only work if you plan them and plan them and plan them and rehearse them and rehearse them.
So I'd just like to finish up. I mean, you mentioned the advance of YouTube, and the information is definitely there. If you follow the right producers, there is so much in-depth information that you can get on all kinds of subjects, not just computing and technology. It's there if you go out and find it. And I think that is one of the great things about the internet and technology today, is that the information is there if you can find it. And it wouldn't be there if it wasn't for the kind of work that you were doing back in the early days of technology. This youngest generation here is so lucky, because they can see the new stuff, they can see the old stuff, they can pick and choose what they want, and they can find the thing that they engaged by and entertained by. And if they're interested in a subject and they don't like the presenter, there's probably someone else that's doing a similar kind of thing in a different style, which would be more appropriate. So it's absolutely amazing. And then just one last thing, which is 1923 for the Radio Times.
1923.
Thank you, Wikipedia. So obviously the museum's open for the rest of the afternoon. So please feel free to have a look around at the displays if you haven't done so already. Take some time to go and look at our special exhibition. And thank you once again for coming along today.
Good. Thank you. Good. Okay.